Hello. Um, Today we'll be doing reverse linked list 2, which is where we're going to be reversing only part of a linked list as opposed. Okay, I guess it's not guaranteed that it'll always be only part of. It could be, the whole linked list. Um, but the whole theory behind it is you're not guaranteed to always be getting the whole linked list, so you have to be able to handle for those situations. Um, so yeah, if you haven't done the regular reverse linked list, probably should do that first, because this is a harder version of it. But besides that, we can get into it. Um, we'll start off with doing the edge case first. So basically, if there's only one node, there's nothing to reverse. Or like, okay, if there's no nodes, obviously there's nothing to reverse. And if there's only one node, there's also nothing to reverse because one node, if there's only one node, it doesn't point anywhere either, right? So we're going to be writing the conditions where if head is none, or head.next is none, then you just return head. So this first one handles for no nodes, and this next one handles for one node, right? So from here, we're going to be doing something very similar from the last question, or like reverse linked list, where we have a previous and a current, and they're going to start off with the values of none and head, because when you reverse the linked list, you have to have a pointer to everything that you want to reference, or else you're going to lose the reference to it, and then that will be very bad because then you can't, do anything with those nodes unless you go back from head and like iterate all the way through. And if you already started modifying the linked list, it's possible you even lose pointers to them. I don't think they're called references to them because there isn't anything that's explicitly called a pointer in Python, I suppose. So we have these for us to reverse with. We have these for us to reverse with. And so we're going to do for I in range of left minus 1. We're going to keep moving the previous and current ahead because left here is where the first node that we want to swap or like reverse, and then right will be the last node we want to swap, right? Or like reverse, not swap. So we want to stop at left minus 1, so we'll have something pointing at the node before the first one we want to swap, and then we'll also have a value for the last node that we have, right? So here we will have so basically when we haven't gotten to the nodes that we want to reverse yet, we will just want to keep moving these forward. So previous will equal to current and current will equal, so it'll just move forward, right? So basically you go from here and then you move forward. So previous is currently here at none, current's here, so you want to point this forward and then you keep moving it diagonally like this forward. The reason why you can't just do previous.next here is because previous initially starts off as none, right? And none doesn't have a next. So you have to move it forward like this. And like you're guaranteed, right? Because it's just, think of it like a line and then you just go through one at a time. And so previous, the next thing of previous will always be current, and then current will just have to find the next thing, right? And so here we'll just keep going until we hit the first node that we want to reverse. And then so here we will have two things. I'll just call them before and after, but you could call them whatever. like you want, right? You could call it like something like the node before sublist, or you can do something like last node of sublist for like the before and after. You can, but I'm just going to call it before and after because it just it saves me the problem of having to type. You could even do something like before and like after, but like I don't know. I think that gets a little bit too confusing. At least this is like explicit saying before and after. And so now, here, we'll just write some notes. This is to get you to the first node that is to be reversed, right? And then here, before is the node right before the list, before the sublist, reversed sublist, and after is the node that will be last after the sublist is reversed, right? And so here for I in range of right minus left plus 1, the reason why we do right minus left plus 1, we'll just use this as an example. So we're doing 2 and 4, right? 2 and 4. There are a total of 3 nodes. 4 minus 2 only gives you 2, so you need to add 1 more on top of it, right? Just so you make sure you reverse all of the nodes. So this will look just like reversing the sublist. And so here, it's just like reversing the full sublist, because this for loop will help guarantee that, you know, you are within the range that you are given here. So you can reverse it just like you would have in the regular reverse linked list problem. So you'll do next node is equal to current.next, and then you'll have current.next is equal to previous, and then you'll have previous is equal to current, and current is equal to next node. Just to make sure, so if we're here, right, previous is here, current is here, that'd be right. Yeah. So basically you want for you want, so currently this would be, before would be here, after will be here, right? Which are also previous and current. So next node will be here at 3. Current dot next will equal to 1. I'll just point out 1 currently, and then previous will now point at this will now point at 3, and then yeah, so it just screws up this thing dot next because 2 will point at 1, but that will be fixed later on. Right now we just want to change the direction of, I mean, it's changing the direction of this arrow, this arrow, this arrow, but we'll get that fixed afterwards, so it's not too big of a problem. Oh yeah, and so when this arrow changes this way, this one will disappear because yeah, it just won't this can't have 2 next, right? So if this next is here, this next, once we write this dot next, it becomes this one will just disappear. Yeah, and so this is how you would just reverse it. And then so after you reverse, if before is none, then you have to do head is equal to previous. Oh no, before, sorry. Huh? Wait. Oh no, it would be equal to previous. Yeah, because if this case will only occur before, like, if you don't do this at all, then previous will equal to none, right? And so here this will equal to previous. So if basically if this never happens and you're reversing from the very first node, then you just make head equal to the previous thing, and because previous will be the first part of the reverse node, like the reverse list, and then yeah, so you just put that there. Else you would have before.next is equal to previous. So basically, if there's no node before, which will be the case, you got to start reversing from here, then you would just set the head to the previous. So let's just say we're reversing only this part, right, from 1 to 4. After you reverse, ideally, it would be 4, 3, 2, 1, right? And previous will be here. Current will be pointed at this. Well, like, yeah, would be here. And so if it wasn't pointing at anything, then you want head to be pointed at this instead now. And then you want the last node after dot next to be equal to the new current. Because, so, for example, if we were to do this question, right? So 1, 2, 3, 4, 5, right? If this is the original list and we want to sort from 1 to 4, after we're done, it would look like this, right? Or like the ideal solution would look like this. And so basically, when we do this, there's nothing to sort, right? Because previous will be pointed at none, and then current will be here, and then so current will have the value of 1, which would become after, and before would be none. And so we still need something for the head, right? And so that means we sorted from the very first thing, so we need to make head the new value of 4. And then yeah, if we only wanted to sort from here to here, then our before would be here. So then we can do before.next is equal to previous, which is the new first node. And then, but yeah, that's kind of irrelevant right now because we're sorting this whole 1 through 4 area. And so we sort this, and then so current will end up pointing here, right? And then after was the first node of the list that we wanted to reverse. But now that's at the end, right? So 1, and then 1's here now, and then so that's why 1.next is equal to the new current, which is at the very end of the list, whether it's a node or not. And so here we return head because we want the whole list, right? And then any of these values could give us something before the after the actual head. So since we want the whole list, we want to return head here. And then yeah, so here it works. Feels good, man. Thank you for watching.